Welcome, this is Mr. Anderson, and this is a Chapter 8 review. I want to look at the first 5 problems of the rational expression review sheet. Problem number 1, y varies directly with x. Write the direct variation equation relating x and y when x equals 2, y equals 4. Direct variation, we have this relationship, y equals some constant times x. And then we need to find this this constant in order to have this this equation that's asked for in the instructions. So let's plug in 2 for x and 4 for y, and we'll solve for this constant here. Y is 4, and x is 2. Divide each side by 2, and we get that constant is 4 divided by 2 is 2. Plug this back into our general relationship equation, and we get y equals 2x. All right, so there is our equation. And then the second part, find the value of y when x equals negative 2. So just plug in negative 5 for x. Y equals 2 times negative 5, which is negative 10. All right. So y equals negative 10 when x equals negative 5. All right, take a look at number 2. Y varies inversely with x. So now we have this general equation. We've got y equals some constant divided by x. There's that inverse relationship between y and x. We need, again, to find this constant in order to develop the equation. Plug in 12 for x, negative 3 for y. So we got negative 3 equals k divided by 12. Multiply each side by 12, and we see k equals negative 36. Plug this back into our original equation, and we have y equals negative 36 over x. So there is our inverse variation equation. Now we need to find y when x equals 8. So just plug in 8 for x. Y equals negative 36 over 8. And we can simplify this. Looks like we can divide the top and the bottom by 4. So that would be negative 9 over 2. And there's our answer. You could say negative 4.5. That's an exact decimal, so that'd be fine. Next problem. Z varies jointly with x and y. So we have this relationship right here. We have z equals some constant times x, y. And exact same thing. We've got to solve for this constant in order to develop this joint variation equation. Let's see, z equals 48. Solve for that constant. X is 8, and y is also 8. All right, so we're going to divide each side by 64. We're multiplying by 64, so divide each side by 64. We find that k equals, k equals 48 divided by 64. And it looks like we can divide the top and the bottom by 16. Divide the top. 48 divided by 16 is 3. 64 divided by 16 is 4. So there's the constant. Plug that back into our general equation, and we have our joint variation equation for this specific situation. Z equals 3/4 xy. You could say z equals 3xy over 4. That would be good. Maybe even more useful. All right, then we have to find specifically z when x equals negative 1 and y equals 7. So same thing, plug in x and y. Equals 3, and I'll write it as 3xy over 4 this time. X is negative 1. I just think it's more useful. Over 4. All right, so what is this? This is negative 3, negative 21 over 4. And there we have what z equals in that situation. Okay, let's go on to 4 and 5. Write an equation described by each sentence. X varies directly with y and inversely with the square of z. All right, so x varies directly with y. So again, we have some constant, and it varies directly with y, so that's going to be in the numerator. There's that direct relationship between x and y. And inversely with the square of z. So we got z squared, and that shows the inverse relationship. All right, so this right here, there's the relationship we have. X and y directly related, and x and z squared inversely related. All right, let's take a look at the next one. Z varies inversely. All right, let's get our constant in there. And anything that's inversely related, I want to throw in the denominator over here. Anything directly related, I want to throw in the numerator. All right, so z varies inversely with both x and the square root of y. So it's inversely related to both of these, so both of these are going to go in the denominator on the other side of the equation. X and the square root of y. All right, there we have it. All right, hope that was helpful.